Hello everyone. I'm going to talk about the mid-segments of a triangle. So let's start off by just drawing a triangle here. Triangle, we'll call this ABC. Now the mid-segment of a triangle is the segment that connects together two midpoints of two sides of a triangle. So if I find the midpoint of side AB, maybe we'll call this M. Because that's the midpoint, I know that these two segments are congruent to each other. And if I find the midpoint of one of the other sides, so let's say we find the midpoint of BC, about right here, right in the middle. So these two segments are congruent. And let's label that N. The midsegment of the triangle, or one of the midsegments, is this one that connects together these two midpoints. Okay? Every triangle has three midsegments. So if I find our last midpoint, about right there, maybe let's label that one P. So then these two segments are congruent. With this last midpoint, I can draw in two more midsegments. So we have the one from M to P and from N to P. So in our drawing here, MN and NP and the segment MP are all midsegments. And together, those three midsegments, as you can see, they form a little triangle. So triangle MNP is what we call the midsegment triangle. Okay. So let's finish up by doing an example of using one of the midsegments of a triangle. So here I'm given some information. I have triangle JKL, and it's got these vertices, -6, 1, -2, 5, and 2, -1. And then this tells me that M is the midpoint of side JK, and N is the midpoint of KL, and I want to show that MN is parallel to JL, and that MN is half as big as that. So why don't we start by graphing our triangle, just to see what we're working with. So J, -6, 1, 1, 2, 3, 4, 5, 6, and then up 1. K is -2, 5, 2, 1, 2, 3, 4, 5. And then last one, 2, -1 for L. 1, 2, down 1. So J, K, and L. So here's our triangle. The other thing I need is I need M, the midpoint of JK, and then N is the midpoint of KL. So on the graph, we might be able to visually see where those are going to be. If not, we also have the midpoint formula. So the midpoint formula, add the two x values together, divide by 2, add the two y values together, and divide by 2. So why don't we start by doing the midpoint of JK. So J and K, these 2 points here, so our two x values, -6 and -2. And then the two y values, 1 and 5, divided by 2. So our midpoint, see, that's going to be -8 divided by 2 is -4. And that's going to be 6 divided by 2, 3. So 1, 2, 3, 4, and then up 1, 2, 3. And that one is M. Okay? Let's do the same thing for N. So we need to find the midpoint of KL. So our two x values for KL, we have -2 and 2. -2 plus 2 divided by 2. And then our two y values, 5 and -1. Okay, so this should be N, but M for midpoint. So that's going to be 0 divided by 2 is just 0. 4 divided by 2 is 2. So 0, 2, there's point N. And connecting those together, we get a midsegment. Okay. So then what we actually want to show, what we're actually trying to do, is we want to show that MN is parallel to KL. And we also want to show that this length is half the length of this one. Let's start by showing that they're parallel. The easiest way to show that two segments are parallel in the coordinate plane is to show that they have the same slope. So we can count the slope here if we would like to, or we can also do the slope formula. So why don't we do that? So for JL, the slope formula again, you subtract the y values up top, and you subtract your x values down below. So for JL, the two y values, we have 1 minus -1, and our two x values, -6 minus 2. So we end up with 2 over -8, which is -1/4. Let's do the same thing for MN. So our 2 points here, the two y values, 2 minus 3, and the two x values, 0 minus -4, which also ends up being -1/4. So they have the same slope, so therefore they are parallel. The second thing we need to test is we need to show that the length of MN is half as big as JL. So to figure out their length, we can do the distance formula, which would work, or we can also use the Pythagorean theorem. So you have options. Either way works. To use the Pythagorean theorem, we want to drop in this right triangle. And if I look at these side lengths, this is 1, this is 4. And then let's do the same thing for JL. So we drop in the right triangle here. Okay, so this is 2, and then from -6 to +2, that has a length of 8. Okay, so MN, so we have 1 squared plus 4 squared is equal to the hypotenuse squared, which one we just called that x. So this is 1 plus 16. So we get 17, so MN is the square root of 17. And now doing the same thing for JL, we have 2 squared plus 8 squared is equal to, and then why don't we call this one y. So 4 plus 64 is equal to y squared. So then we get y is equal to the square root of 68. Now, comparing these two, it's not directly apparent right away, but we can simplify the square root of 68. So 68 is the same as 4 times 17. And now using the product rule for radicals, we can split that up into the square root of 4 times the square root of 17. And the square root of 4 is the same as 2. And now we can see, comparing these two lengths, that this is just twice as big as that one. So, based on that, because they have the same slopes, the midsegment and this side are parallel, and based on their distances, we can see that JL is twice as long as MN.